Hey chemistry crew, Mr. Collier here. I want to go over the gases simulation. So the first thing we need to do is highlight the link and go on over to the sim. So over on the sim, you've got the laws, and then you've got this little playground for yourself. So the first thing we're going to do is pump some gas into it, right? And then the first question is, observe the pressure. Now add a second pump of gas, and what do you notice? So I noticed that it went from 5 something to 11 something, so adding more gas increased the pressure. So for this first one, you'll notice the answer was additional gas particles added to the same space increase the pressure. The next thing it asks me to do is reset the sim and then try the other size gas particle with 2 pumps and compare it. So remember, we were at 11 something over here. So let's reset it. Oops, it's under my picture. Reset it. Click on the smaller gas particle, and again, we're going to give it 2 pumps. 1, 2. Notice that it is still 11.7. So the fact that we gave 2 pumps of a smaller gas did not matter for the overall pressure. So here's my answer. The 2 different size gas particles have equal pressures when they have equal amount. Boom, there we go. Now for the third one, we're going to start changing other variables. We're going to use 2 pumps of gas, and we're going to change the size of the container. And then the question is, what happens when we cut the room in half? So back to the container here. Here's the little handle. I can make the container bigger. Notice that the pressure just went down. So now if we cut the volume in half, and I'm just kind of estimating here, notice that the pressure goes up. So pressure and volume, right? When I have less space, notice the gas particles are bumping around more. More collisions means more pressure. So if you cut the volume in half, you increase the pressure. The next question here, there's a menu about holding variables constant. Let's keep the volume constant, and then go to the little bucket and raise the temperature. What happens to the pressure? All right, so here I'm going to hold the volume constant, and I'm going to heat it. So I drag the heat up, and notice that I get a little flame, and notice that the pressure, right, if you look at the pressure gauge, it's going up and up. So now my pressure is much higher. So heating the gas has made all these particles move a lot faster, which has increased the pressure. So back here, what happens to the pressure when you heat a gas? The pressure increases. Boom. Okay. And now here's your last one. Let's keep the pressure constant and cool the gas. What happens? All right, so let's see if we can keep the pressure constant and try to cool it. Now, yes, here, I want to show you this. Oops, pressure cannot be held constant. The volume would be too small. So we might need to reset it here. So I can try fiddling around with variables, but it might just be easier to reset it and start over. So I'm going to keep the pressure constant, and now I'm going to cool it. Notice that as I cool it, the room is shrinking. So if the pressure has to stay the same, the room is going to shrink until you get to a point where it can't shrink anymore. Okay, so here, as I cooled that gas, it took up less space. That's actually what happens in like a balloon on a cold day, right? The gas particles get closer and closer together as they cool, and so your balloon is a little sad looking. And so that again would be the volume decreases, right? So the volume of the room shrinks. That last one might have been tricky if you had trouble with the room getting stuck at a too small size. So that's it. I thought this was a pretty nice simulation of how you can change things like volume, right? How you can change temperature, heat, cool, and how you can change the amount of the gas. So play around with that and let me know if you have any questions.